Alrighty, question 4 is about solving simultaneous equations, and for this question we need to solve for both x and y. Now the reason we're given two equations is because we have two variables, and if we just had one equation then it would be impossible to solve without knowing either x or y. So we need to use them together or simultaneously to get the solution for x and y. First things first, I will label the first equation equation 1, second one equation 2. Then from there, where I have y in equation 2, so 2x plus 4, I will substitute into y into my first equation. So I will write that here. I'll say substitute equation 2 into 1. So then I will have 4x plus 3, then in brackets where I have y, I will put 2x plus 4, and that equals 6. Thereafter I need to expand this middle part here. So I have 4x, that does not change, plus 3 times 2x is 6x, and 3 times 4 is 12. That equals 6. Then I have 4x plus 6x is 10x, plus 12 is 6. Then I have to take 12 from both sides to isolate my x, because I'm trying to solve for x. And with that, these 12s will cancel out. What I'll have left is 10x is equal to negative 6. Then I will divide 10 on both sides because I'm trying to solve for x again. So these two 10s, 10 divided by 10 is 1, and I'll be left with x being equal to negative 0.6. Now that's just partly my solution. I'm not quite done yet. So I now need to solve for y. So I will substitute x equals negative 0.6 into equation 2. That equation I will rewrite it here. Y is 2x plus 4, and I will then substitute my negative 0.6 into x. So I'll have y equals 2 times negative 0.6 plus 4. Y equals negative 1.2 plus 4, and y is equal to 2.8. And that's my solution. So I've found x and I've found y. All right, we're going to move on and go to question 5 and do that one as well. So in question 5, it says find the equation of the line that is perpendicular to this equation here. We've been given some extra information and we've been told that it passes through this point 1, 4. Alrighty, so first thing we need to know to be able to solve this is that if it's perpendicular, the two equations, their gradients, if we multiplied them, I'll call the first equation's gradient m1, second one's m2, they should equal negative 1. That's an important piece of information that you need to know. Alrighty, so if I have got my original equation that's given to me, y equals 3x plus 5, the gradient is 3. Always remember the general equation for a linear equation is 3y equals mx plus c, where m is your gradient. Okay, so if m1, we're going to call this one m1, is 3, we need to find what m2 will be, so the gradient of my second equation. Then I can basically find m2 and c, so that will give us our new equation. So if m1 is 3, I will then use this formula to find what m2 is. So I'll substitute m1 to be 3. 3 times m2 is equal to -1. If I'm looking for m2, I'll have to get rid of this 3 by dividing 3 on both sides. So 3 and 3 will cancel out and give me 1. So that's gone. And so m2 is -1/3. So what I've got so far is I've calculated m2. Now, this new equation of ours should be in the form y equals m2x plus c. I already know what m2 is. m2 is my -1/3. So I'll rewrite this and say y equals -1/3 x plus c. Now, we're not quite done yet. We know that it passes through the point 1, 4, and you will use that to find c. Once we've found that, that will be the equation that is perpendicular to our original equation, y equals 3x plus 5. Alrighty, so I'll say substitute 1, 4 into the equation. We will have y equals, or y is 4, we already know that, 4 equals -1/3, where x is, I'll put 1, plus c. So that'll be 4 equals -1/3 times 1 will just give us -1/3 plus c. Okay, from there I will add 1.3 on both sides. So I'll just rewrite this to make some space. So I will add 1/3 on both sides so that this -1/3 and +1/3 can cancel out, give me 0. And what will be left on the left hand side here is 4.3. 4 plus 1/3 will give me 4.3 equals c. So I've calculated what c is. Alrighty, so my final answer is going to be y equals -1/3 x plus 4.3. Right.